some of these I won't rehearse fully, but I will tell you where I put marks and so on. So here's part A, part 1. And we were asked to prove this, a very standard result. Okay, so 2 marks. The first mark was for an appropriate choice of substitution. Okay, so you said, you know, let u equal, and then most of you chose this, which is probably the most straightforward way to say it. So if you let u equal to that, then you can work out d on dx, which is -1. You can work out your new boundaries, which are flipped upside down, and it's no dramas from there. It's a very straightforward thing to do. The second mark that I was looking for was after you did the substitution, and you put it all in, and you formed your new integral, okay? Probably the most critical step was the reversal of the boundaries. I didn't really pay all that much attention because I didn't have that much choice, only 2 marks, to the change of variable, changing all the u's back to x's. I didn't think that was such a big idea. I think this is more important, and some people even missed it, a very small number of you, okay? So, we've got those 2. Now the reason why it's important to start there is because you needed to use this part properly to get part 2. Now I know it doesn't say hence or anything like that, but they're trying to lead you in that direction. And particularly when you have a look at what they're asking you to prove. Whoops, sorry. You've got this is I1. And then you've got this, which is I2, which has nothing to do with recurrence relations, by the way. They were just using that as notation. And I don't think anyone got confused by it, but still. Not pi minus x. Okay, now I had to smile to myself when I saw this question. Because remember, I did not write this paper, right? But I know that people had specifically asked me, I think almost this exact question before I had seen the paper or anything like that. And I was kind of did a silent yes, you know, because I was like, you guys should be, I mean, there's a couple of little twists and turns to do this, but I had shown them to you, at least the people who asked me, okay? But still, some of you fell down. I think probably the biggest opening error was that you just didn't use part 1. You didn't use part 1. You don't have to use part 1 to do it. They don't constrain you to do that. But it becomes hard to do it in other ways. So here's the way that I did it. I started from this line over here, I1, okay? And I said, I want to get to I2. That's what I want to do. So all I did was I saw that this thing here is built on what these boundaries are, A and B. Here, they're 0 and pi. Okay? So all I did was I rehearsed the result from part 1 in part 2 with these specific values. That's all. Okay? So most of you, your first line should have been this. Okay? Boundaries stay the same, 0 to pi. But everywhere I see x, I'm going to replace it with 0 plus pi minus x, because that's what A and B correspond to in this particular question. Okay, so I've got an x there, so that should be 0 plus pi minus x. I've got another one, 0 plus pi minus x, and then I've got one last one here, 0 plus pi minus x. Okay, now at this point, several of you dropped an easy mark, and I'll admit it was very strict, but I'm trying to communicate this to you so that you get this for next time and do it properly. If you wrote this, but you left out the zeros, so you just wrote pi minus x, pi minus x, pi minus x, okay? Very likely you lost a mark there, okay? Now you're like, really? Plus 0? Come on, we know that plus 0 doesn't change it. And I'll admit it's a very, very small difference, and I ummed and ahed over whether I would do it or not, okay? What it came down to was, if you pulled out this line, you needed to connect it to the result that you got it from, right? And this result, there's something there, right? Pi minus x, it could be something completely different. It could be, and some of you actually did this, it could be an identity that has to do with this. B, yeah. Right? With no lower boundary in sight, okay? So I needed you to demonstrate that you had gotten it from here, and the cheap way to do that was to say, A, in this case, is 0. It's an actual number, right? It just so happens that it evaluates out. The only way you could get away with not saying the 0 and still get the mark is if you'd done something like this. If you wrote it out without zeros, cos squared. But if you had said over here from part 1, you see this explanation, right? This line here, which, you know, most people are like, I don't need to include that. This is the demonstration of understanding. Now I can see where you got it from, right? Whereas if it's not there, it could have come from somewhere else, right? I know it's the same, it'll end up as the same, but the point is that you need to demonstrate how you got there, right? It is, after all, a show question, so you've got to show the steps in the rationale. So I think that's a better line to go with, and then you simplify out. Okay, now, there was the first mark, I think, for actually using that part. So there's one. Then when you do this, most of you saw, okay, that's really good. I've got the pi minus x at the front that I'm after. That's cool. All I need to resolve is these two guys, okay? Now you had to be careful about the way that you did it with respect to x, okay? Now, I would say the best answers, not necessarily, you didn't have to do all of this to get full marks, but the best response would say, okay, what can I do here? Sine pi minus x, what's that equal to? That's just equal to sine x, right? Okay, and even if you didn't know that identity, you could see that you were going there, right? But it's nice to actually include that. Now, at the same time, so I've got my pi minus x here, and now I've got sine x there. This is a tricky one. A couple of you lost this even though it's very, very small. You can't say the same of cos pi minus x, right? Because cos pi minus x is not equal to cos x, right? What's it equal to? It's equal to negative, right? You can look at the graph and you can see it. So therefore, if you went straight from here to here, yeah, that was a bit dicey, okay? If, again, you'd actually said on this side, it's equal to negative, so I saw that you had used the correct identity, and then you squared it out and you skipped a line of working, that was kind of okay. But if you went straight there without saying this, it doesn't make clear that you know what identity is going on. A better way to say it would have been this, because that squared applies to the whole function, right? So I think this would be a better way to articulate it. And then you don't need to say this, it's clear what it's equal to, okay? So once you've gotten rid of that double negative, then you get to I2, cool, you're there. All right, so just to rehearse, the first mark was here for the use of part 1 correctly, and the second mark was in the use of both of these identities to actually get there, okay?